Detecting radioactivity. We can't see or feel radioactive particles. I mean, they're smaller than atoms, right? But we can detect them by looking at the interactions that they have with other atoms or molecules. So we're going to talk just about a couple of different ways of detecting radioactivity. One method is using a thermoluminescent dosimeter. So dosimeter, this is measuring the dose of radiation. And so these are generally in the form of a badge that someone working with radiation would wear on their lab coat. And it's going to collect radiation as the person is working with it. And so at a certain period of time, it could be a week, a month, the badge will be analyzed to see how much radiation the person has been exposed to make sure that they're within a safe level. The way it works is it has crystal salts like calcium fluoride. Calcium fluoride gets excited by ionizing radiation. So, these particles that are emitted. So the electrons that get excited by this are going to be trapped by impurities in the crystal that were put there on purpose. So we don't use pure calcium fluoride, it's got some impurities in it. So the electrons get trapped, and then when you heat the crystal, it will release the energy of those electrons as light, and that will be proportional to the radiation exposure. So we can use this to monitor exposure of people working with or near radioactive substances. Any questions? So, someone working in radiology at the hospital is probably wearing a badge like this. Something you've probably seen in cartoons, if nothing else, is a Geiger counter, or a Geiger-Müller counter. And this is the thing that, they're carrying around, and it goes click, 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 or beep, beep, beep. And the more beeps, ooh, this is, dangerous, we better move away, kind of thing. Measures radioactivity in real time. How does it do this? Well, we've got a tube here filled with argon atoms, and we apply a high electric voltage. So looks a little bit like a battery. We have the cathode up the middle, and it's the anode. Anode up the middle and the cathode along the outside. And so electricity is trying to get from the cathode to the anode. From the anode to the cathode. But it can't just jump, electrons can't jump through gas or vacuum, right? And there's just argon in here. As radioactive particles, ionizing radiation comes in, it will ionize some of the argon atoms into ions. And then an argon ion can carry electrons from one to the other, and so you'll see some current pass. So you measure the electrical signal, and that is generally displayed on a meter. This is an analog meter or a digital meter, and it can also be turned into an audible click, which makes it, just easy to quickly tell, are you getting close to radiation or not? Any questions? A scintillation counter also detects radioactivity in real time. And here we set it up so the radioactive emissions pass through materials such as sodium iodide or cesium iodide that will emit UV or visible light because of the excitation by those energetic particles. So then the light can be detected and turned into an electrical signal, which can be read on a meter. But these are not typically the kind that you can carry around.